These problems here in Chapter 3, they're similar to the ones in Chapter 2, but now instead of having systems of equations, we're going to have systems of inequalities. So instead of equal signs, we're going to have less than signs or greater than signs. These problems come out of a section called linear programming, and they are going to be similar to the problems we did, the word problems we did back in Chapter 2 with systems of equations, but these are going to be systems of inequalities. So rather than equals signs, we're going to have less than signs or greater than signs. Now I'm going to do two problems here at the same time. I'm going to do, because one leads into the other, I'm going to do 5 in 3.1, and this is 13 in 3.2. One of them refers to the other. So here's what's going on. You got a truck that goes from New York to Baltimore, and it's loaded with two types of cargo. All right, so I'm thinking two variables. Now each crate of cargo A is, all right, you read through some information. Each crate of cargo B, there's some information here. The truck can carry no more, all right, Bob, a bunch of information here. Now, just a bunch of information. Then, we're just supposed to set this up in 3.1. But then when we get to 3.2, we can solve it. But we can do this all at once. So 3.2, it says this. Go back to 3.1, this problem right here, and answer this question. How many crates of each cargo should be shipped in order to satisfy the shipping requirements and yield the greatest earnings? So I'm going to set this up into a matrix. Now, we've got what? Crates A and crates B, and then we have some kind of a total here. Now, the way I'm going to set this matrix up is this. I'm going to have the categories across the top. I'm going to put the categories across the top, and on the rows, I'm going to put the characteristics of each category. So my categories are my variables, right? A is going to be my crate A, B is going to be the crate B's, and what do we have? Well, we have volumes, we have weights, and then we have earnings in each one. So we're going to have, say, volumes, weights, and then earnings. So I'm going to separate these off. I know it looks a little vague now. We'll see how it goes. Now what we're looking for is this. Down here. How many crates of each cargo? So I'm going to let X be the number of crates of A that we should use, and Y be the number of crates of B to use. Now, what do you know about A? Let's go back up here. What do we know about A? Right, each crate of cargo A is 4 cubic feet. All right, now that's the volume. So I'm going to bring that 4 right down here. And what else do we know? It weighs 100 pounds. So each crate weighs 100 pounds. Now what do we know? All right, and it earns $13 for the driver. So we have earnings of $13. Okay. Now what about B? Let's go over to B. Here's what we're given. Each crate of B is 3 cubic feet in volume. So for B, the volume is going to be 3. And what about, it weighs 200 pounds. So we're going to have a 200 here. And how much does it earn the driver? $9. Okay, so the driver earns $9 for each one of those. I'll separate this off. Now, what else do we know? Well, the truck can carry no more than, all right, no more than, all right, that means less than or equal to 300 cubic feet. Now, that's a volume. So when I write that over here, I'm going to leave a little space here. Okay, leave a little space and write your 300. Now, what do you know about the weight? Let's see, no more than 10,000 pounds, right? So the truck can carry no more than 10,000 pounds. So I'm going to leave a little space. I'm going to put 10,000 over here. Now, these are not equals necessarily. It says no more than. So that means that these could be less than or equal to 300, less than or equal to 10,000. Now, what I'm looking to do here is, see down here at the bottom, it says this. How many crates of each? So what should X be? X will be the number of crates of A. And what should Y be? That will be the number of crates of B. How many crates of each type, A and B, should be ordered to satisfy these requirements, but yet yield the greatest earnings? So here's the earnings. What we want to do is maximize that, right? Maximize this number right here. Get that to be maximum. So find the values of x and y that make this as big as possible, but they still have to satisfy these constraints. But we've also got something else here. These are called the non-negativity constraints. Now these are applied problems, so we're counting the number of crates of something. So the x's always have to be greater than or equal to 0, right? No negative numbers, and the y's always have to be greater than or equal to 0. These are called the non-negativity constraints, and they always appear. So what I've written here, right here, that is the linear program. And that's really problem number 5, and then you get to number 13, and we're actually supposed to solve this. So to keep these videos from getting too long, why don't we do this? Let's solve this system here in the next video.